I am back for part 2 of Neuroevolution with Flappy Train. I don't know, Flappy something. You can see here, I now have this neural network which is driving this circle to jump, get through the... Oh, it's not really working. So the problem is I only have one. I need to make a population of them so that I can pick and choose the ones that are making smart decisions somehow and making their way through this maze of pipes. But before I even do that, in the chat, thank you to Christopher, a mistake was pointed out, which is that I forgot that my neural network library, just like it expects as its inputs an array of values, it gives you back as its output an array of values. And I forgot about that because even if it's one value, it's still coming back in an array. So I need to say index 0 here. So what I want to know is that first element of the array, is it greater than 0.5 or not? The truth of the matter is nothing's really happening yet, so we're kind of getting the same results. But you can see things are possible. All right, so now let's see what we can do here. The first thing that I need to do is I'm going to make a new JavaScript file, and I'm going to call this ga.js. So I'm not going to make a population class or genetic algorithm class. I would like to at some point refactor what I'm doing here into a packaged way that you might be able to just like use it as a library, as part of the toy neural network library, has some functionality for genetic algorithms built into it. But I'm just going to write all the raw code here. And the main thing that I need to do first is I need to change the idea of having a single bird to many birds. And I want to, I'm going to use const. Woohoo! So exciting when I use const. I'm going to make a population, total, I'll just call this like total, and I'll make it 100. So what I'm going to do here is I'm going to say I equals 0, I is less than total, and then I plus plus. So I'm going to make a population of birds. Birds index I is a new bird. Then what I'm going to do here is let me just do this here. For let bird of birds, I'm going to use that for of loop to just loop through and have every bird think, update, and show. Now I haven't done I got to fix this thing with the pipes. So let me just comment this out for a second, but let's at least see the whole population going. So you can see, it's kind of interesting. It's definitely like they're doing different stuff. Now, they really are. All right, so one thing I want to do here, just visually, I want to be able to get a better sense of the birds. So I'm going to look at the bird's show function, and I'm going to say stroke 255 and fill 255, comma 50. Like I'm going to give them some alpha. So you can see that most of them are doing exactly the same thing. There we go. There's sort of a variety there. One thing, I'm just kind of a little suspicious here. Let me try 2 outputs. Let me see if 2 outputs actually yields some more unique results. So in that case, with 2 outputs, what I actually just want to do is something like if output 0 is greater than output 1. So let's try that for a second. It's kind of the same. Maybe I just want to have a bigger population. Yeah, there we go. I just had a bigger population. So I just want to have a bigger population because I'm going to need more possibilities. Okay, so now here's the thing. I need to do something else rather important. I need to eliminate any birds when they no longer, when they hit one of the pipes. So now what I need to do is as I'm going through here, I also want to say for let j equal birds.length minus 1. J is greater than equal to 0, j minus minus. And I could use filter or something, but I'm not going to use filter. I'm going to come back to that another time. And then what I want to do is I want to have this. If pipes index I hits birds index j, birds.splice j comma 1. So this is now me deleting any birds that stopped living there, that hit one of the pipes. So let's run this and see, sketch.js error. Oops, I forgot a semicolon here. Okay, let's try this. All right, so let's see here and see if we can get, did any of them make, none of them made it through. That's not a good sign. So I would like to at least kind of live in a world where, so I'm going to make it a little easier for them. Right now in pipe, I'm going to make this, I'm going to increase the spacing to 175. So I'm just going to make that space between the pipes a little bit easier. Oh yeah, one made it through. Because I just want to at least kind of increase the chances that there will be some that outperform others. And I'm somewhat random, but let's see. Okay, so this is good. Okay, so we're getting somewhere. Now what I need to do is I need to think, what are the things I need to think about when I have a genetic algorithm? Okay, so a couple things. Number one is I know I'm going to need to have a new generation. So let's actually, let's write a function called next generation. And just for right now, I just want to get sort of like the process going here. For next generation, I'm going to say for let I equal 0, I is less than total, I plus plus, birds, index I equals a new bird. And I know that in the main program, if at any point birds.length equals 0, then call next generation. So now if I run this, we should see that at least it's going to let these run as long as there are some birds. And then next generation is not defined because I forgot to add it here to my index.html file. So I need yet another JavaScript file. I'm going to call it ga.js. Okay. So now, as soon as all of the birds run out, 2 made it through. No, oh, come on. Whoops. Did I forget to hit save? Next generation. I put it in library/GA. Okay. Come on, let's move it along, folks. All right, one more time. Let's, with feeling, everybody. Oh, look at those 2 birds making it through. Oh, look at that, genius. That is a genius bird already. Come on, go, you can do it. Oh, I jumped right over it. Oh my God, this is amazing. Come on, go up. Oh, okay. So you get the idea here. Now, I haven't involved in that. Was very exciting for me. My life is very strange. Okay, so what I need to do, though, is this is no good. I don't just want to make a whole new set of new birds. I want to evolve them from the previous generation. So in order to do that, I need some sort of fitness. And so I'm going to build into each bird object, I'm going to give it a score and also a fitness. And it's probably not necessary for me to have 2 variables, but the way I'm thinking about it right now, it's just going to make it easier. And so the idea is that the longer a bird lives, the more it increases its score. So in update, right, every time update gets called, it should get another point. So I'm going to say this.score plus plus. Okay? So every time update is called, its score goes up. And then what I want to do at the beginning of next generation is I want to calculate a fitness for every single bird, and I want all those fitness values to be normalized between 0 and 1 and add up to 1. And if you watch some of my previous genetic algorithm tutorials, you'll see why I'm doing that. I need each fitness value to be a probability that it gets picked for the next generation. So the first thing I'm going to do in next generation is I'm going to calculate all the fitness values. So let me break this out into some functions. Calculate fitness. So in calculate fitness, what I'm going to do is for every bird, I am going to, first I need to do is get the sum. So I want to say, I know I could use a higher order array function here, but my brain doesn't think that way. Sum plus equal bird.score. So what I want to do is first add up all of the scores. Then, for each bird, I want to say bird.fitness equals its own personal score divided by that sum. So this is a way of kind of calculating and normalizing all the fitness values. Now maybe I need to make this exponential in some way, or be, power law or some kind of fancier way to think about how the score maps to fitness. But this, I'm just going to use this sort of like linear way of doing it right now. I could square the score. So let's see, fitness equals bird.score divided by sum. So this works for calculating all the fitness values. Now I've calculated all the fitness values. I then need to, I'm moving right along here. Then what I need to do is I need to pick, all right. Let's hold on for a second here. All right, so if you remember from it, or if you happen to watch any of my genetic algorithm tutorials, I go through this presentation which walks through the actual algorithm itself. So what I need to do, so I have evaluated the fitness of each element of the population, but here, if you look at the next step, I need to make the new population. I need to n times pick 2 parents with a probability according to relative fitness. This is so that I can apply this idea of crossover. Take half of the DNA of one and half of the DNA of others and mix them together. Here's the thing. I'm going to, for the purpose of this video, do a simplified version of crossover. One way that I could do a simplified version of crossover is not do crossover at all. Instead of taking 2 elements and combining them, I could just take 1 element and make a copy. So I'm going to take the ones that do well and just make a copy of them. And the reason why this is going to be so easy, because I already have, as part of the neural, over here, as part of the neural network class itself, a copy function. And guess what? I have a mutate function. And if I come back over here, we're going to see the next step is mutate. Mutate the child's DNA based on a given probability. So this is what's nice, that I did this in a previous video. I added these things to the neural network library that I'm using. So now I'm going to go back. Oh, and let me just minimize this. I'm going to come back here, and I'm going to say instead of just making any new bird, I need to pick 1. I need to write a function, pick 1, that is going to somehow return one of the birds based on with a probability mapped to its fitness. So here's the thing. Where are all the birds? Where have all the birds gone? I kept deleting them. Anytime it hit I deleted it. Here's the problem. I think I need a backup. What's going to be nice here is say let birds equal an empty array. I'm going to have an array called saved birds. And I guess what I could do is, maybe what I'll do, this is a little bit silly, but every time I delete one, I'll just say saved birds dot push pipe, because I'm pretty sure if you delete something from the array, it returns, right? If I say pipes index 0 dot splice 1, pipes splice 1 0 comma 1, right? I get that pipe object. It gives me that pipe object. Oh, it gives it to me as an array. So what I need to do, but I think I can push the array into it, and so this should work, right? If I now have, if I make an array, which is an empty array, and then I say oh, shoot. Okay, I know the picked one. Here, hold on. No loop. Thank you very much. No. Okay, now I can do what I want. I can do whatever I want. Let P equal pipe splice 0, 1. So P is this array with 1 pipe into it. Then I could say let A be an array, A dot push P. And so now let's see what A is. Oh, A is an array with 1 thing with a pipe in it. So that works. All right, just testing out my idea. So what I can do now is when I'm done, back to sketch, right? As I'm removing the birds, I can save them. So that now when I go into the genetic algorithm, pick 1, I can pick 1 out of the saved birds. So let me just, for the sake of argument, just say let child equal random saved birds. Return, I just want to see that this works. Right? So I'm just going to, I'm not using the fitness yet as a probability, but I just want to pick a random one just to see that the workflow works. Return child. So birds index, and then I'm also going to say child.mutate 0. I'm going to have a 1% mutation chance. So I'm going to let it mutate, or 10%. I'm going to mutate 10% of the weights of the neural network, and then I'm going to return that. So let's just see if this works. And then after I'm done that, I also have to clear the saved birds. So empty that out. So this now, every time I want to make a new generation, I should calculate all the fitness values. I should get however many new birds, clear out the saved birds, and go again. So here we go as I'm waiting for the next generation. Come on, birds, you're doing too well. Child.mutate is not a function. Of course, child.mutate is not a function. Oh boy. Okay, there was a little bit of a jump cut there because I really went off some like weird direction there that made no sense. I don't know if you noticed and were yelling at your television machine thing that you're watching me on, but for some reason I put this down here. I started adding the pipes to the saved birds. So apologies for that. This is not where that goes. The pipes get removed just when they go off screen. It's the birds that I want to add to these saved birds. Also, I'm not so sure. I might be making an array of arrays. Let me just run this for a second. Let me let a bunch of birds die. And let me look at saved birds. Yeah, I made an array of arrays. We don't want that. We want an array of birds. So I could probably use concat. But let me just push in the one thing that I'm removing just to fix that. And we can see here is there's no birds in there. And then now I have an array of birds. All right, so that's better at least. Now, pick one is still going to have a problem. So why is pick one good? I sort of stopped thinking about what I was doing here. I'm taking that bird. I'm not making a copy of the bird. I'm taking that exact bird object and putting it back into the birds array, which is fine. But if I want to mutate it, I need to mutate its brain, the neural network. So to do that, I think what makes just as a quick, I could just say, like, let's put in the bird class itself, let's write a mutate function. And mutate function, I'm going to say this.brain.mutate 0.1. So I'm just going to kind of have this hard-coded in here that when a bird mutates, its brain mutates. And I think I can get away without actually making a copy of the neural network. Oh, no. No, I want to make a new bird with the same neural network. I think I'm going to be better off. Because otherwise I've got to reset all of these numbers and values. Its velocity's got to go back to 0. So I want to make a copy of the bird. And I kind of want to, but I don't really need to make a copy. I just need to make a new bird with a brain. So if brain, right, if I create a bird with a brain, a bird brain, then I'm going to say this, and I'm going to make a copy of it just for, it's probably unnecessary, is brain.copy. So I'm going to do that. If otherwise, if I'm making a bird without a brain, I'm going to just make a bird with a new blank neural network. And there's already a copy function. This way I'm setting myself up for future success. If I want to do crossover, it's going to be a little bit easier. Then here, what I want to do is in pick one, I pick a random bird, but I return, and then I say, let bird equal, and then I'm going to say let child equal a new bird with that bird's brain. Oh, this is very weird. And then I'm going to say child.mutate. Okay? And then now this should get me the right idea, right? I'm picking a random bird out of the saved birds. I'm making a new bird with the previous bird's brain. I could do crossover here, right, if I want to do crossover, and then I'm mutating. Okay, so let's give this a whirl. Here we go. Did they all die? I don't have a console log for, yeah, there we go. Okay, so this is working. I probably should clear out the pipes. So the other thing I should do, I think, is, that would make sense, is when also, as soon as there's a new generation, I should probably say pipes. I should just like, let me just add one pipe. And actually, you know what I'm going to do? I'm going to make this my own counter. This is a little bit unnecessary, but I just want to reset the counter back to 0. Counter plus plus, and I'm going to have a global variable. Whoops. Sometimes I can't type. I'm going to have a global variable called counter set equal to 0. Okay? So I just want to do that because I want to, I don't want to, I want the whole game to restart. There are 2 pipes though at the beginning for some reason. Why is that? I'm looking at sketch.js. Because I add a new pipe in setup, which I no longer need to do because as long as I put this first in draw now. Okay, there we go. Okay, so now there's one pipe. All the birds are trying to play Flappy Bird. As soon as they all go away, the whole thing starts over. So now we have the workflow. We're actually good to go here. We are good to go. The problem is I need to pick them based on their fitness values. Here's the good news. I have a function. This comes from my traveling salesperson coding challenge. It comes from this GitHub issue that was filed on August 5th, 2006. With this particular algorithm for picking an element from a population based on a given fitness. So I'm going to go over to here actually, and I'm going to grab this exact pick one function, and I am going to bring it over, and I'm going to put it in this. So if you want to review how this function works in more detail, you can go back to my previous videos, but I'm just going to paste this right in here. And the idea here is that at the end, list index is that particular bird that I want. And this made I don't know why I have slice here. I can't remember why I did that. But basically, what I'm doing here is now instead of picking a random one, I'm going to pick it from that list. Now, I wrote this function with arguments, but the good news is I can take this stuff out, and what I'm really doing is I'm saying, okay, birds index.fitness, that's the probability, right? I'm picking one thing from a list based on probability. Those were the arguments here. I'm picking something from a list based on an array of probabilities. So now, wherever I see list, what I mean is birds, and whenever I see probability, I mean birds fitness, the fitness of the bird. So this is birds index, and I don't know why I have that slice there. And then, so this is good. I'm good. There we go. So this is an algorithm for choosing a random number and seeing where it falls into the sort of spread of all the probability values. And again, you could go back to my video where I specifically talk through this entire algorithm. But I think this is going to do it right now. So let's now run this code. That's really the last piece. And I'm going to let this run for a little while. And no, I'm not, because cannot read property y of undefined. So what did I mess up here? Let's take a look here. All right, I clearly made a mistake. Thank you to IHORL in the chat. I need to be using saved birds. Remember, birds has nothing. So I need to say saved birds, right? Saved birds. So that is something I definitely need to do. Is that the problem that I'm having? I think I might have a different problem also. Yeah, so I think because once all the birds are gone, it's kind of doing this one more time. I have 2 functions called pick one in the code. Did I not even realize that? So I have a lot of undefined, a big array of undefineds. Did I leave oh my goodness, I left this function in the code. Why is that there? All right. Let's see if that was using this other pick. Okay. Next generation. All right. We're getting somewhere now. Cannot read property fitness of undefined. Okay. So here we go. Cannot read property fitness of undefined. So let's take a look at saved birds. And let's take a look at index. All right, here we go. This is a lot of debugging in this particular video. All right, whoa. What? Line 16. Oh, it was going through all this. It got through all of them. Weird. Are the fitness while r is greater than 0? All right. And then what happened? And then we got to the end. Yeah, of course, because it never. So let's look at the array of 250. First of all, let's make our life a little bit simpler by just doing this with 10 birds while we're trying to debug this. And that way we can have an easier time of figuring this out because there's only 10 of them. So lift, velocity, I want to check the fitness values. Fitness values of all these are 0. So my fitness calculation is somehow messed up. Let's look at that. So let's look at calculate fitness. Let's console log sum. Okay, let's console log sum. I have to wait. 0. That's not good. Bird.score. Let's look at all the birds' score. Whoops. Score is 96. Score is 96. So that's right. They're getting a score. Oh, I need to do saved birds here. Saved birds. So everything here has to be saved birds. I probably should do it the other way around. Okay, there we go. The fitness calculation also needs saved birds. Probably everybody in the chat has been telling me this for like the last 5 minutes. So now I feel pretty confident here. I probably shouldn't. I'm going to take out my console logs and let's see what happens. Let's see, can we get to the next generation? Yes, we got to the next generation. Now, am I seeing anything evolve? I don't think so because I only have 10. So let me give myself a lot more birds. Let me give myself a lot more birds. Back here, I'm going to say, let's give myself 350 birds. And let's run this sketch. All right? I'll be back in just a few minutes. All right, so this did okay. They seem to be improving. There's some good ones in there that are jumping, but I'm going to wrap up this part 2 where I finally applied the actual genetic algorithm part to evolving the neural network with a population of these things. And what I'm going to do is I'm going to do one more part where I'm going to improve this. I'm going to do a few things. Number one is I'm going to speed up the process so I can get it to evolve a lot faster. And I'm going to change the way mutation works, which I think will give me it will help me find an optimal solution a bit faster. So come back if you want. I will be here again in part 3.